Welcome guys, I'm in the chem lab right now and I'm going to be doing a demonstration lab for you that will help you understand some of the concepts that relate to solubility product equations and the constants that we derive from them. I've set up a little set of equipment here, not very complicated. I'm going to move this around a little bit so you can see better. In the squeeze bottle here we have distilled water, which is what I have in the first beaker. In the second container I have sodium oxalate, which is in this beaker. And the final container that I have is one containing calcium nitrate. And what we want to do is we want to put these solutions together in a very measured way in order to form a precipitate. I'm going to show you a little graphic that does the explanation of the reaction that's going to take place. You're going to be able to see on the website for Moodle that I've taken these images and made them into still images, but you'll be able to look at them a little bit more in detail if you go to the Moodle website. But just let me hold this up for a second. The reaction we're going to do is one that we see at the top here with calcium nitrate and sodium oxalate reacting. They will produce calcium oxalate, and sodium nitrate is the leftovers. The calcium ion, this is in the second reaction, reacts with the oxalate and produces a solid precipitate of calcium oxalate. So the forward reaction, shown with the arrow there, is indicating that the calcium oxalate is a product. But the third reaction down, I take that product and I reverse it and I make it go back to being calcium and oxalate. Final reaction at the bottom shows that there's an equilibrium between the calcium oxalate, the calcium ion, and the oxalate ion, and that's represented by the double set of arrows. All the solutions that we have here are aqueous, with the exception of the calcium acetate, or calcium oxalate rather, that is a solid. So that's the little illustration of what we're going to try to do. The piece of equipment that is going to be critical to this is a set of very tiny test tubes, as you've been accustomed to using in what we call a well plate. You're familiar with this. And this one has 96 wells in it. Each of them the same size, and I already have some solutions in them. If I tilt them, chances are they'll stay in, but I just don't want to flip it vertically. But it gives you a sense of what we're looking at. This kind of equipment is used very much in hospitals. It's used to analyze things in industry, where you can do a whole bunch of analytical work at one time. And right now with the virus, these kinds of tools are very useful for them testing a lot of samples in a short amount of time with automatic machinery. It can put a bunch of testing samples into a little well plate like this. So it's very convenient for us. Let me show you a graphic again, which I've made a magnified version of. In the top row, we're going to have cells, a cell, or wells rather, A, and there are 12 cells going from left to right. In the second row down is what we call row B, and there are also 12 wells in that one. So what I've done is I've filled wells for row A with one solution, and all the wells for row B with the other solution. And then I have that. The top row is going to contain calcium nitrate. The row B is going to contain the sodium oxalate. And then if I bring this up a little closer here, I have already put 5 drops of water in wells 2 to 12. I'm going to put 10 drops of my calcium nitrate in the first well on the left. So all the wells after that have just pure distilled water in them. but that first well, A1, will have the 10 drops of calcium nitrate. And then in row B, all of these wells have 5 drops of sodium oxalate in them, all the way across from 1 to 12. And again, you'll see this graphic when you go on to the Moodle page. What I want to next show you is that we're going to do what we call a serial dilution, meaning a series of dilutions. We're going to go across the top set of rows, row A, and into the very first well, number 1, I'm going to be putting the 1/10 molar calcium nitrate solution. And then I'm going to take half of that out and put it in the next well. And as soon as I do that, when I transfer 5 drops from well 1 to well 2, I will have made a solution in well 2 that is 0.05 molar. Then I will take 5 drops of that solution and transfer it to well 3 in row A and mix them, and that will make a solution that is half the concentration of the one previous to it, or 0.025 molar. And we're going to go through the whole sequence where we take 5 drops out of a well and transfer to the next one. We'll return what we don't transfer back into the well. And by the time I get way over to well number 12, the solution's concentration is very small. And you can see we are down to 0.00045 approximately molar. The solution in row B is all the oxalate solution, sodium oxalate, and there's no change in concentration there because we're not doing any mixing or diluting. So this is called a serial dilution, in other words, a series of mixtures where we constantly are lowering the concentration of one of the ions in here. So let's take a look at the procedural step. This is again using the well plate, and I've done these other solutions, or I'm sorry, I put all the reagents in here already that we need, with the exception of that calcium nitrate on that top left well. And then I'll show you how we do the series of dilutions. Once we've done all that, we're going to mix the cells of B with those of A, and when we do that, it'll form, we hope, a precipitate, and then we're going to analyze that precipitate. So I've tried to not make things too boring, but this next part will be a little bit boring because I'm just mixing the calcium nitrate in here. So let me take some calcium nitrate, got in the barrel pipette. Okay, so there's my 10 drops. If this was a Globetrotters game, basketball game, those boring moments when nothing's happening, we start to sing Sweet Georgia Brown. But we don't have to do that here, unless you guys want to hum it at home. I'm now going to take the barrel pipette, suck up all the stuff that's in well 1. I'm going to move it over to well 2, and I'm going to drop 5 drops into well 2. Calcium nitrate back in well 1. As soon as I put the barrel pipette down here in well 2 and draw up the liquid, it'll mix. Now I'll put 5 drops of it into the next well. Okay, so hopefully we have a bit of a dilution there. All right, and now what I'm going to try to do is mix cells in row A with cells in row B. So I'm going to suck up the liquid that's in the top row, put it over into the row B. I just have to go down the line doing this. The barrel pipettes are not too bad in terms of the volumes that they transfer. They're not as accurate as are some of the expensive pipettes, but at least they're a cheap version. Final well. Okay, our results aren't too bad. I'm going to turn this now, and I'm going to try to get it so it doesn't reflect light from some stray sources. Okay, and we're looking at row A having been combined with row B, and I'm looking straight across row B here, and I can see the precipitate is formed in the first approximately 5 wells, and down in this well here it starts to fade out, and it's imperceptible almost in the next well here. It's hard to see anything. Now, what's important here is that you take note that we are in well 6, where the solution stops, forms a precipitate, but the next one, there's no precipitate. That's an important piece of data. So write down well 6 is the last one to form precipitate. Now, to wash this out, all I have to do is shake it upside down real quick. My solution's in the sink. I do a little rinse, shake it a couple times. And my well plate's pretty clean. The last graphic that I want to show you is the one where we do some of the math. Typical of all equilibrium constants, you want to be able to take the product concentration and compare it or put it over top of the reactant concentration. For the KSP value, that would mean that my ions of calcium and oxalate, my products, when the calcium oxalate breaks down, would be put in brackets over top of the calcium oxalate. But something that you learned in the video the other day was all solids have steady concentrations, so we don't even write a concentration for the calcium oxalate on the bottom. We just put a 1 in there, and we don't even have to write that. We can simply put the calcium ion and the oxalate ion in brackets, figuring those out from which well and which concentration in that well formed the precipitate. So once you do the math on that and multiply those two concentrations, you'll get a KSP value that's based on your experiment. And then what you want to do is compare that experimental KSP to the accepted KSP, which you'll have to look up. You might be able to find it in our book, or you might have to actually just look online. And then from that, figure out what's the percent of deviation of the accepted value from our experimental value. And that kind of gives you a little idea how this lab would be done. You normally would have been in the lab here doing this. I tell you the most difficult part is getting the drops to be evenly equal volumes. Sometimes you can be off a little bit. Ours worked out pretty good. When my students do it from time to time, that's the area sometimes where there's little mistakes. But having done it for you, you now have the background. You give a sense of how to do it, how it was done. When you go to do your lab report, as said on the Moodle page, you're going to be putting in the typical things for a lab report: title, purpose, procedure, your data, calculations, and your conclusion. Once you have that all put together, and that shouldn't take much more than a page, do your calculations. You might have to go to the second page, but do your calculations very clearly and show your values and put a conclusion in, and then just take a good photo of it, or in some fashion get it to me through an email. You can either type it or you can handwrite it very neatly, and I'll be able to examine it and grade it for you. And that'll be our class work for today. So as soon as you've done the lab report, submit it, hopefully by the 2:40 mark in the afternoon,